So this is introduction to algorithms, part of the subject algorithms and complexity. Welcome guys, and let's proceed to our discussion. The analysis of algorithms is the theoretical study of computer programs, performance, and resource usage. When we talk about program performance, it is more on the characteristics of a program, on how it act on a particular problem or solution. And there are some characteristics. How do we measure program performance? And resource usage. It's on the study how a program utilizes different resources of your machine, such as memory, the hard disk consumption, the access point or access how fast the accessing the data, something like that. So what are more important than performance, or what are considerations to measure the performance of the machine? First is the modularity. Modularity is the use of individuality distinct functional units. In programming, as we develop systems, systems are divided into different components or modules, and it being connect or integrated together to perform the whole operations as required by the problem, or to make the whole solution. Next is the correctness. The program should not only produce correct result, but must produce them with unlimited time. Don't wait for how, it's along with the speed, correct? And it's within the time as expected the program to provide as the correct result. That's correctness. And then we have maintainability. Maintainability meaning it, it is a characteristics of a software quality. How easily a system can be modified or enhanced. That is maintainability. Another is functionality. Oh, robustness. Robustness is the ability of a computer system to cope with errors during execution and cope with erroneous input. How the system detect some invalid input, how the system manage erroneous input, trap some problems, or detect some errors. That is robustness. User friendliness. Is the software interface easy to use? Is it friendly to the user? Meaning it is not difficult to learn and understand. Programmer time. Yung time to develop, time lead. Kumbaga, saan ba ma-deliver yung software or solution or the program itself. Reliability, simplicity, extensibility are some of the performance indicators of a program. Reliability testing is done to test software performance under given conditions. Tested na ba how the systems work with the different scenarios? That's how to measure the reliability of the system. The objective is performing reliability testing are to find the structure of repeating failures. The programmer's time naman is in connection with quality, time, and product are all delivered within the time frame. Simplicity is of course, no, along with performance yun. Extensibility is a software engineering and systems design principle that provides further growth of the program. Extensibility is a measure of ability to extend a system at the level of effort required to implement an extension. So, pwede ba siya ma-enhance? So, extend the functionality or no, open ba siya for further enhancement yung application or software na yan. And along with that is analyzing the different approach or algorithms kung paano nila gi-design yung pagiging user-friendly. Isa likod sina is the solution or the codes or the algorithm behind of that so that it can deliver a good quality and achieve better performance sa application or application. So why study algorithms and performance? Algorithms help us understand scalability. Performance often draws the line between what is feasible and what is impossible. If you know the parameters of how you evaluate the performance of the application, then you know what is feasible and what is not ideal. Algorithmic mathematics provides a language for talking about program behavior. Performance is the currency of computing. The lessons of program performance generalize to another computing resources. If you know the way to measure the performance of the computer or the program, then you know how to compute the resources of how the program uses the resources of the machine. And that's in effect, always remember that the speed is always find the the way how fast the program deliver correct result. Okay, and that's always the measure and the uh, way, no, that's why in algorithms is when you study algorithm in advanced topics, no, oh you look for some algorithms tapos you study its drawback and try to develop much better because you want mostly ginatanaw nila ang speed ng algorithm na yan. Pag hindi siya ideal yung speed performance ng algorithm niyan, then most of the researchers mga nag-study sa performance ga-design sila ng bag-o na algorithm out of the existing algorithm because they think that the new approach is much better and much faster than the existing algorithm. So later on, you will learn that there are different algorithms na pare-pareho naman sila mag-search ng data but they have different approach because they are considering the speed as one of the performance indicator of the application or the program. The study of algorithms started, you know, beginning to appear in three things. The compendium of algorithms for solving standard problems. They use mathematical techniques for analyzing behavior of algorithms in terms of performance on input datasets of various sizes. So how do they analyze the algorithms? They use different input data and its effects. No? That's why when you try to compare one algorithm to another algorithm, you have to apply the same data set so that you can compare it fairly. taxonomies or classifications by family of algorithms that reveal their underlying strategies and illuminate the issues involved in the design of the novel algorithms. They try to look at it, the content, the structure of the algorithm, so that they can study the underlying strategies. No? What are the issues out of that existing algorithms so that they can address the issue, they can develop much better algorithm than the novel algorithms. Algorithm is not a program. Although algorithms are the foundations of program. A program is the product of both algorithm and a data structure. When you program, when you try to solve a solution in a programming or in programming, you first select relevant data structures, which to model your elements of your problem inside the computer. What you mean by model your data structure in which you model your problem? Like, what are the variables, what are the data, kailangan. Those are the terms na referring ng data structure. Then you think of yours as you think of your solution to your problem, which may be defined into individual operations such as sorting a number, set of numbers located in particular record, and so on. How will you do searching? Kasi you try to solve a particular problem na mag-search or mag-sort ng data according to name, number, or whatever requirement of the system or the program. And that is what you mean by a program and algorithm. So next is we will discuss the relationships of data structures and algorithm. See you on the next slide.